Today I'm going to talk about our field trip in 2020 that we went to Ethiopia. This research was a collaboration between LMU University of Munich and the German Archaeological Institute, and this research is funded by DFG, which is German Research Foundation. Okay, the city that we did the prospection was in Yeha. It is located in north of Ethiopia in a region named in the Tigray region. It is not so far from the UNESCO World Heritage Site, Aksum. And Yeha itself is a very important city for us, as it was the political and religious center of the community of Diamat and later for Aksumite Empire. Since 2009, it is under investigation of an Ethiopian German team. And the best preserved Ethiopian buildings in this area are Great Temple and Grasbe al-Gibri. So in here you can see the Great Temple, which is dated back to 7th century BC. And it is dedicated to the main Sabian god, Almaka. And it is a 18.5 by 15 meter building with a maximum height of 14 meter, built with a dry masonry engineering technique. And later in 6th century AD, the temple was converted to a monastery based on the baptistries that you can see also inside of the temple, which was added after on. The second monumental building is Grasbe al-Gibri, that is decided based on the evidence that it was used as a palace. And this building is a 60 by 60 meter with a maximum height of 27 meter, and it had 5 floors. This building is constructed in wood stone architecture, and it is the largest known timber framed building in East Africa and South Arabia. In here you can see that our colleagues, this is inside of the palace, and our colleagues are trying to reconstruct it. So the beige part in here are showing the stone structure, and the black part is showing the wood structure. Moving on, our geophysical prospection started with a large scale magnetometry in 2018, and we continued in 2020 with Synterex magnetometer and geometric magnetometers, which both were cesium magnetometer. But measurement was not always easy for us. As you can see, this is our magnetic grid. During our measurements, that always the animals were passing by. There were always so many children around, in general people around. So it was not always chilled and easy. So in here, sorry, I guess some of the mics are on.
I'm sorry.
Yeah, it's fine. So in here, we can see that the overview of our magnetic prospection. And in total, we managed to measure 31 grids. We had several challenges, such as modern infrastructures like pipes and modern buildings, magnetic field boundaries, and in general magnetic rocks over the surface. And we were so close to the geomagnetic equator. Therefore, magnetic interpretation was so challenging for us. So these problems highlighted the necessity of using the second instrument in this area, and we chose to use ERT instrument in 3D form, and this part was my part in this project. So after analyzing our magnetograms and checking the result of open and backfilled excavation trenches, we chose the Shilanat area that you can see in here, the magnetogram of it. So the blue rectangle is showing the position that later on the excavation conducted there. So in here you can see a picture of the excavation. As you can see, we have 2 layers of structure. The first layer is assigned to Aksumite period, and the second layer, which in here is not yet excavated completely, is assigned to pre-Aksumite. So our task was that we realized with ERT if this substructure is extended to the east part of this excavation trench. So here you can see a general situation of Shilanat area. The instrument that we use for ERT is a 4-point slide instrument manufactured by Erich Lippmann. And this area is confined from one side with a metal fence and from the other side with a sudden depression. And to obtain a trustable result, we needed to be far enough from these two disturbances. Therefore, our area of prospection was not so big at the end. But this area was so important for us, as the locals wanted to open a bus station there, and they stopped our excavation. And actually, during my measurements, they were causing trouble for me also, that I stopped my measurement. And we wanted to prove that there are some substructures and archaeological substructures happening there. So, but for our measurements, for our 3D measurements, the way that we want to measure was by measuring several 2D parallel profiles and then collecting the data at the end. And we want to check the change in resistivity values with respect to changes of soil temperature and moisture and the conductivity of the topsoil. So we set a 2D profile and measured it repeatedly at first during the day, during one day. So it was something like a time-lapse measurement. And then next to it, with the second instrument, TDR instrument, we measured the soil temperature, moisture, and the conductivity. And then we plotted the resistivity results and compared each result with respect to their soil characteristics. And then at the end, we saw that the values are not changing by these during the day. Therefore, we could proceed with our 3D modeling. So here you can see the 3D model of our first area. So in here, the x-axis is showing the length of our profile, which was 20 meters, and the y-axis is the direction that we made our parallel profiles. And each color is showing the different resistivity values, and each one of these figures is showing different depth slice. So in area number 1, we managed to measure 12 parallel profiles with half a meter spacing and also half a meter distance between the parallel profiles. The black lines that you can see here are the interpretations that we did over our ERT results. As you can see in here, up to here, we can see some structures that we can say there are walls, and from around 1 meter, you can see that a new structure, new substructure is starting to appear. That it can be the one of the evidences that we say that the excavated walls are extended in the east part, and according to values, we can say that these walls are also made out of stones. So for understanding the resistivity changes with regard to depth, I made a video that you can see that at first we have the first layer of the substructure with the walls, and by going down at around 1 meter, we are starting to see the second wall, which is appearing. So we can say that this is also a multi-layer structure. So moving on, we wanted to see also if at the northeast side of the first profiles, the set of profiles, we can see some, if this substructure is extended there. Therefore, we managed to measure a second set of parallel profiles, which that area was even smaller comparing to the first area of measurement. We managed to measure 6 parallel profiles with the same situation as before. So this area is so small, so it is not easy to interpret it and just according to these data, and finding a pattern is not easy. But at least we can say that we are seeing some anomalies. And also, again, when we go around 1 meter deep, we can see that second styles of anomaly are showing up. So the thing that we can just suggest from this second set of profile is that it is possible that that substructure extended in that direction as well. So again, I made a 3D visualization of resistivity values with respect to depth. And you can see the changes of the resistivity. And again, at around 1 meter, you can see that these new sets of anomalies are showing up. So So, as the final point, I overlaid our depth layers over our magnetograms, and I try to see if we can see some anomalies that are visible in both magnetic and in 3D ERT. So the part A that you are seeing here is the third depth layer, which is between around 40 centimeter and 60 centimeter over the magnetogram, and the part B is the fifth depth layer of ERT modeling that is around between 90 centimeter and 1 meter 20 centimeter. So the blue lines are the interpretation lines, that the anomalies that we are saying we can detect in both magnetic and in ERT. And although by just looking at the our magnetograms, we were not able to say if these anomalies have the geological or the archaeological origin, but by taking a look at ERT results and also comparing them afterward with the magnetic results, we are now with more confidence able to say that these anomalies have the archaeological origins. And now we are hoping that with this data, we're able to stop the locals for making the bus station and continue with our excavation. So thanks for your attention. And as we're going to publish this data, I would be so happy if I hear any suggestion or comment.
Thank you very much, Mandana. Do we have some questions to this interesting presentation? So I would like to ask you if you're considering some further research with additional methods, perhaps.
I mean, right now there is a big trouble there, and there is a war in Ethiopia, and it's exactly the same place that we were measuring, so I'm not sure how will it be for the further prospection. But right now we don't have any plan for using another instruments there, but we will see. There's always space for further prospection.
Sure. And regarding the COVID situation, is it theoretically possible to travel? I ask for this because my advisor is currently in Salvador, so that might seem a bit surprising. So that's my question.
I mean, last year we were so lucky because we were exactly at this time of the year in Ethiopia, and when we came back to Germany, like 2 weeks afterward, the pandemic in Germany started. So right now, I'm not sure if it's possible, but yeah, we will see how will it go in the next months.